Welcome back to 6th grade science. In our last video, we started talking about energy. We talked about the 7 different forms of energy, as well as kinetic and potential energy. If you remember in that video, I mentioned that we'll get more in depth about kinetic and potential energy later on in this year. I'm going to talk a little bit more about it today, but we aren't going to get super specific about it again until we get to energy, focus, and motion. I want to take this as an opportunity to talk a little bit about how science builds on each other. We're going to start at point A, which is where we started in the last video, and work our way to point B. So point A is now, point B will be the end of this year. And over that time, we're going to talk about a lot of different things. We're going to talk about engineering and energy transformations, electricity and magnetism, energy, focus, and motion, and structures and property of matter. So if you look at it, we go in a little bit of a line. But at the same time, engineering and energy transformations is connected to energy, focus, and motion that we're not going to talk about for another 4 or 5 week rotations or so. But it's also connected to structures and property of matter, which is connected to electricity and magnetism. In science, everything relates. And you can see this on this lovely diagram that's all over me that kind of looks confusing, but all it's showing you is that science as a whole relates. You can't have one part without the other. It's kind of similar to math in that sense. If you noticed, over the years you guys have done math by learning how to add, then subtraction, multiplication, division, but no matter what you learn, you use the bases that you created earlier on. Science is the same way. You learn something, and then you learn how it relates to it, and it builds on one another. All right. Now let's get started with going a little deeper into the different forms of energy. So really quick, let's jump in and go to a new location. Mechanical energy, if you remember from the last video, is the energy of movement. Now don't get this confused with kinetic energy, which is the energy of moving matter. Mechanical energy is both kinetic energy and potential energy because it's the energy of moving matter, which remembers kinetic energy, or it's items that have the potential to move, which falls in line with potential energy. Remember gravitational potential energy? If I'm holding this boulder right here on my hands, it has gravitational potential energy because it's above Earth's surface. At the same time, it has mechanical energy because it has the potential to move. So when I drop it, the movement that it just did is kinetic energy because the matter was moving. Next is chemical energy. And remember, chemical energy is the energy stored in the bonds between different atoms, like this one. When those bonds are broken, chemical energy gets released and transformed into a different type of energy. For example, when I break this pen cap off, I just broke a bond and energy was released. It's a similar idea to that. Obviously, bonds are a little bit smaller than pencil caps, otherwise we'd see them, but the idea is the same, that chemical energy is stored, the bond is broken, and chemical energy is released. Next up is electrical energy. Remember when I turned the lights off and then I ended up turning the lights back on? That's electrical energy. Electrons move through conductive material, and when they do that, they create an electric current. So when you turn the power switch on and then turn it off, you're essentially allowing an electric current to begin and travel through wires and then end once you turn it off. We're going to get into electricity and magnetism in not this next 5-week rotation when you guys will have social studies and English, but the following 5-week rotation. So we're going to talk more about it then. Electromagnetic energy is the energy that travels through space as both electric and magnetic waves. There's all different kinds of examples of electromagnetic waves, and I'm going to show you a few here. These examples include light. Light is a type of electromagnetic wave that travels from the sun to here. It also includes radio waves. When you're riding in a car and you're listening to the radio, or if you have a radio at home and listen to it, then radio waves are traveling from the thing sending the radio waves to the radio, and that's what the antennas are for, to collect those radio waves, and then your car turns it into sound with the different programs and wires and all that fun stuff. Another example of an electromagnetic energy type is a microwave. And I don't mean the appliance that you probably have in your kitchen or know someone that has in their kitchen. The microwave itself uses microwaves, the little tiny things that you can't see, to cook or heat food items. So the microwave uses microwaves. But when you think microwave, I want you to think of the electromagnetic energy, not the appliance. If you've ever thought that you've broken a bone, you probably went to the doctor's office and got an X-ray. An X-ray is another type of electromagnetic energy. And the last example that I'm going to talk about for electromagnetic energy is the gamma ray. You might have heard of this before in different TV shows if you watch sci-fi or movies or video games. They go through and people oftentimes are reading radiation and they're talking about gamma ray radiation levels. That's the gamma ray. The next type of energy is thermal energy, which is the energy of moving atoms in matter. All matter has thermal energy because atoms are always moving, even if it doesn't seem like it. So, for example, take an ice cube. Ice is solid, right? So it's not moving at all. Atoms aren't moving. That's not true. In ice, there are tiny, 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 tiny little things called atoms that we'll get into when we get into structures and property of matter. But the atom itself is this tiny little thing that's moving around constantly. But it's so packed together, it's moving like this instead of moving like this all over the place. Since ice is a solid, the atoms are moving, but they're moving at a much smaller rate or a much smaller speed than they are in things such as water, for this example. Water has atoms moving, and you've got instances where water moves through a river and it's running water, or you turn on your tap and water comes out and it's moving water. It's not the same idea. Water sitting still, if I had a drop of water here on the counter, there's still atoms moving in the water. They're just moving quicker than they are in the ice because it's a liquid, so they can move around a little freer. And then you have steam. Steam is gas form of water, and it's hot, and the particles, the atoms, are moving around a lot more. So they're moving around so much, they have a lot more thermal energy. Now notice I said that steam is hot. What temperature is ice? Cold. You're right. Ice is cold. Steam is hot. Notice that ice is cold, so the atoms aren't moving around as much, but steam is hot and the atoms are moving around a lot. Thermal energy does have something to do with, you guessed it, heat, temperature. The hotter something is, the more thermal energy it has, and the colder something is, the less thermal energy it has, and that has to do with the amount that the atoms are moving. Now, beyond that, something that has more mass has more thermal energy. So you can have a 1,000 pound ice cube and a tablespoon of water. Even though it's cold and they're not moving around as much, your 1,000 pound ice cube will have more energy than your tablespoon of water because there's more mass to it. So the more mass you have, the more thermal energy you have. Why? Because the more mass you have, the more you have of something, the more atoms it has in it. And the more atoms you have, the more thermal energy you have. Next is sound energy. Technically speaking, sound energy is kind of a subcategory of mechanical energy. And the reason that is because it starts with a vibration in matter. So when you think matter, you probably think of things like the marker, different things like that. But matter also includes you. As far as matter is concerned in science, it is a thing. It's existence. This jacket is matter. My shirt is matter. My beard is a type of matter because the hair is matter. So your vocal cords in your throat, which are allowing sound to create, are matter. And the vocal cords vibrate, which causes sound to come out. And remember, we went into the bio a little bit, talking about how it goes into the hair cells in the ear, the vibrations cause different hair cells, and then you end up hearing things or processing things. But we're not going too far into that other than I just talked about it right there. Basically, sound is a type, or sound energy is a type of mechanical energy because vibrations start in matter, the physical substance. Sound energy is a little bit of a different type of energy, because if you think electrical energy, it has to travel through a conductive material for it to work. But sound energy can travel through almost anything. It can travel through air, water, other substances, but it cannot travel through empty space. So think of empty space like literal space. Or I guess, let's travel to space really quick. Oh, I'm glad we're out of space. If you noticed, I was asking you if you could hear me. I was saying, hello, hello, can you hear me? But you couldn't hear me because I was in space. Space is an empty vacuum, and there's nothing for sound to travel through. Right now, around me, there's air. And so the vibrations that my vocal cords are causing allow the sound energy to travel through the air to get to their location, which is you guys. But when I was in space, I couldn't talk because there was nothing for the sound to travel through. It essentially, my vocal cords caused the vibration to get the sound energy going, but no vibrations went anywhere, so it didn't work. The last one to cover is nuclear energy. Nuclear energy is the energy stored in the nuclei from the strong forces holding the atom together. So when those strong forces get broken apart, the nuclear energy is released. All right, I know I covered kind of the same thing that I did with the different forms of energy, but I tried to go in a little more depth. These are things that you're going to hear over and over and over again because, like I said at the beginning of the lesson, science builds on each other. So right now we're developing the base layer so that we can build the next steps on it. Next, we're going to talk about energy conversion. This is the process where one type of energy changes into another type of energy. The same amount of energy exists at point A as it does point B. And that's because of the law of conservation of energy, which states that energy cannot be created or destroyed. With energy conversion, you go from one type of energy to one, two, or more different types of energy. And the specific example that I want to talk about that you will see a little bit more about tomorrow is a popcorn machine. And I mean the kind that they have at movie theaters where you take the popcorn and you dump it out and then it's delicious. This type of machine is powered with electrical energy. It's plugged into the wall. So the electrical energy then travels into the heating unit, which produces thermal energy. So you have electrical energy that's then becoming thermal energy. Is that the only type of energy though? What? No, you're right. It's not the only type of energy. Inside that machine, you have the thermal energy that is now heating up the popcorn kernels. And when the pressure inside the popcorn kernel gets big enough from all the heat, the popcorn kernels explode into the delicious treat of popcorn. At that point, the actual popping is a type of mechanical energy. So now we've gone from electrical energy to thermal energy to mechanical energy. When a popcorn kernel pops, you hear it pop. So on top of mechanical energy, in regards to the popping, you're also hearing the sound pop, so you also have sound energy. And remember, I said sound energy is technically a subtype of mechanical energy. But if we count it out, we have electrical energy to thermal energy to mechanical energy, and at the same time as mechanical energy, we have sound energy. So that's 4 different types of energy with all stemming from electrical energy. So it transformed from electrical to thermal to mechanical to sound. You have one type of energy being converted to 4 types. Now, again, the same amount of energy that you had at point A is the same amount of energy that you have, in this case, at point D. To tie everything up for energy conversion, I want to cover kinetic and potential energy. And I know I've said it before, I'm going to say it again, we'll get into the nitty-gritty details for kinetic and potential energy when we get to energy, focus, and motion. But I want to talk about it because not only can you convert from different types of energy, like we just talked about with the popcorn machine, but you can also convert between kinetic and potential energy. So back to the boulder example that I used earlier. I'm holding this boulder right here on my shoulders right now. This one's a bigger boulder, so it's heavier. Right now, it's not moving. It's sitting still on my shoulder. My knees are shaking a little bit, it's a little heavy, but I'm holding it up and it's not going anywhere. So right now it has gravitational potential energy. And again, remember the gravitational potential energy is the potential energy that it has being above Earth's surface. It has the potential to go somewhere, but it's not. So when I throw this boulder, when it was moving, it has kinetic energy. And when it rests over there on the ground, you can't see it, but it's sitting right there, it's back at a resting state, and now it has potential energy because it's not moving. So you went from me holding it with it having gravitational potential energy to me throwing it, it now has kinetic energy, and then at the end, it has potential energy. The same can be done for going from kinetic to potential to kinetic. So in this example, let's talk about sledding. So when you are sledding down the hill, you have kinetic energy because you're moving. When you get stuck in the snowbank at the bottom of the hill, you're stuck, you're not moving, you have potential energy. But then you stand up to go back to the top of the hill to do it all again. You're moving again, you have kinetic energy again. So just like different forms of energy can convert from one form to another or multiple, kinetic and potential energy also convert back and forth. So right now I'm moving my hands, I have kinetic energy. I sit still and I stop moving, they now have potential energy, and then I move them again and it goes back to kinetic energy. When you go from an object being in motion to being at a standstill and then being in motion again, you go from kinetic to potential to kinetic. Or, like I said before, potential, sitting still, to moving, kinetic, to sitting still, potential. So it converts from one form to another form and back and forth. And again, remember with the law of conservation of energy, just because it's going from one type to the other doesn't mean any energy is lost. To wrap it up today, remember that if you guys have any questions, please reach out to your teacher, whether that's Miss Cameron or myself, so we can help you get a better understanding of this. Bye!